Thank you everyone for joining. I'm Brinda Walad. I'm a scientific software developer at RCSB PDB, and I lead the PDB IHM project for RCSB. And we're going to go through, give an introduction to PDB IHM, integrative structure determination, and how to deposit integrative structures to the PDB archive. So we'll just do a brief presentation, a quick demo, and then have an interactive Q&A. If you have specific questions regarding your deposition, or you have examples that you want us to help with, we can go through that. All right. To start with, just a brief introduction to what integrative structure determination is. I'm guessing that many people here already are aware of what it is, but just for the benefit of the general audience, integrative structure determination involves collecting data from many different kinds of experimental methods, like electron microscopy, NMR spectroscopy, small angle scattering, cross-linking, etc., different kinds of information that you can get for a system of interest, putting all that information together and representing the molecular system that you're interested in modeling, converting this data into spatial restraints, putting it all together with any starting models that you might have for your system, and then together building the assembly using integrative modeling methods. So at the core is the fact that the data itself can be heterogeneous. It's coming from different kinds of methods, so it has different types of information, but you want to put it all together to understand the system that you're modeling. Next slide. So this involves, if to archive integrative structures, then because of this complex mechanism of modeling, we need to account for different requirements. For example, as I mentioned, you have restraints coming from different kinds of methods, chemical cross-linking, which could be distance restraints between two residues or sometimes two atoms, small angle scattering data, FRET data, EPR, EM maps that can be coarse-grained volumes. So you have different kinds of information, restrained information that we want to collect. And because the data itself is heterogeneous, the modeling can be also very complex. Like you can have multi-scale models at different levels of resolution. You can have multi-state or ordered state models, conformational ensembles, and models with heterogeneous composition. And as I mentioned earlier, you can have starting models that are coming from experimental and or computational methods that you are starting your integrative modeling investigation with. So all this information that went into your system as input, we need to handle in some form so that we are able to capture the model, not just the model system, but also the input restraints and input starting models, so we can validate the model based on the input data. So that's why we want to be able to capture all this information, and makes it a little bit more complex than your straightforward traditional X-ray crystallography or electron microscopy or NMR spectroscopy experiment. Next slide. So this gives an overview of what I mean by multi-scale, multi-state ordered ensembles. Multi-scale models are models that have atomic and coarse-grained or coarse-grained at different levels of coarse graining. It could be per residue coarse graining or something broader than that. But models at different at scales, different resolution, in different, it could be at the chain level, it could be intra-chain, interchain. So you're coarse graining at different levels. That leads to a multi-scale representation. You can have multi-state models, which could be either conformational or compositionally different states. But the important aspect here is that these states together satisfy your input restraints because the input data is so heterogeneous. So you want to be able to represent them collectively. And then ordered state is a higher level of multi-state representation, where you have some additional information of maybe states in a biochemical pathway or a time-ordered pathway. So we can capture that information. And ensembles are multiple solutions that independently are able to satisfy your input data within some threshold. An example would be your NMR ensemble that you already see in the PDB. All right, so that's a quick overview of what the different levels of complexities, different types of modeling that you get that encompass integrative structure determination. Next slide. So this is a snapshot of different structures that are currently in PDB IHM. Just to give you an overview, you have atomic, coarse grain structures, you have multi-scale, multi-state ordered models, and then you can have different kinds of input data, cross-linking, mass spectrometry, SACS, EPR, FRET, etc. So different kinds of experimental data that provide input restraints for modeling. Next slide. So before I go into the demo or specific deposition workflow, I wanted to give an overview of what the entire data pipeline is. And with the background about integrative modeling, I hope you'll be able to follow why we are collecting certain things and what the significance of this workflow is. So the first step is before deposition, what are the things that you need to collect, you need to have in hand before you start deposition, which is the file preparation process. We only accept MMSIF files. So no more PDB format files because we are not able to represent the complexity of integrative modeling using the PDB files. So start with MMSIF. It's important to follow standard molecule definitions and nomenclature, like how amino acids, how polymers are represented, how standard amino acids or nucleic acids are represented, and other ligands. There is a chemical component dictionary maintained by the PDB that has all these standard definitions and nomenclature. So we need to follow those definitions. Most software tools, to a large extent, do follow that already, modeling software or structure determination software, but there might be some exceptions which might trigger some errors downstream. So it's better to make sure that you follow the standard nomenclature. Another important step in file preparation is to have your experimental data, the primary data that provided the restraints, to be deposited where it belongs. Like, for example, if you're using NMR data, chemical shifts or chemical shift perturbation, or you use then that data should be in BMRB. If you're using chemical cross-linking and mass spectrometry, that data is in PRIDE, small angle scattering data in SAS BDB, EM maps in EMDB. So the experimental data, it's good to already have that process started and submitted because we would need those specific accession codes when you deposit your model in PDB-IHM. The next thing is to have at least a minimal file that is dictionary compliant, the MMSIF file, which is compliant with the core PDBX MMSIF dictionary and the IHM SIF extension specifically created for PDB-IHM. And to ensure that it's compliant, we have certain standalone software support. I have the links here. This is the IHM SIF dictionary. We have the Python IHM toolkit to create compliant files. There is the generic MaxSet software provided by RCSB PDB, which can also create an MMSIF file starting from PDB. It'll make sure that your molecules and the atom nomenclature are standardized. And there is a MaxSet converter provided by PDBJ that can also be used for creating compliant file. So it's good to start with a reasonably compliant file to begin with pre-deposition. And then when you come to deposition, as I mentioned earlier, in addition to the model coordinates that the integrative structure that you're creating, in addition, we need the input spatial restraints, the starting models, the modeling protocols that help us understand what was done and what is actually needed, how to validate the structure, that's important. And then we need reference data. Part of that reference data is this experimental data that I mentioned that has to go into the corresponding repository. In addition, you would also want to provide reference data about your molecular system, like your sequence, what is the UniProt accession, if it is in UniProt, or if it is nucleic acid, GenBank accession, any kind of other reference information that's useful downstream for users to find your structure and use it in appropriate ways. So we need that reference data and other metadata about the software used or the sample preparation or author citation, that kind of information. So all that makes the data fair, findable, accessible, interoperable, reusable. So the whole point of archiving is to make that make the data fair. So all this is important. So that's the goal of making sure that the deposition process captures all this information. And then we go on to curation. We make sure the data is compliant. It has everything that's needed. We carry out validation based on all the information that's provided. By validation, we mean these are community recommended validation methods to make sure that the structure is based on the data that was used for modeling. We use MolStar for visualizing the structures. You can, in the deposition interface, MolStar is integrated. So you can actually visualize and see, is this the model I'm depositing? Does it look good? Does the ligand look good? There are no obvious errors, that kind of information. And recently, last year, we started providing PDB. IHM is now part of the PDB archive. So you get PDB accession codes once the curation process is completed. And a big part of our curation process is communicating with the depositor. That's why you see these double-sided arrows, making sure if there are any errors, we go back, fix it, come back. It's an interactive process. And then we put the entry on hold following PDB conventions, PDB practices. And when it's ready for release, there are two parallel processes that happen. Now PDB IHM is part of the PDB archive. So you can find it alongside experimental structures in the PDB archive. And you can also find when the structures are released, they're also released on the PDB IHM website. So that's the overall pipeline, data pipeline for PDB IHM. Next slide. So coming specifically to the deposition process, what are the pathways to deposition? There are three mechanisms recommended. The most commonly used mechanism is you start with a minimalistic MMSIF file with coordinates. You upload that and then add additional information through the web interface. And this additional information it can be the restraints, the starting models, and all the other metadata that I mentioned. That's the most common pathway. Then the other method is if you use a tool like Python IHM or the modeling platform called Integrative Modeling Platform, which also uses Python IHM internally, then you can create a compliant file to start with, which means you can add all this information already preloaded into your MMSIF file that you're starting with. You can incorporate your restraints, your starting models, your metadata, including author names and samples and reference data and everything. It can already be part of the input file. You can start with a near complete file, and then you can just upload it via the web interface and skip all the intermediate steps that you need to do manually via the web interface. You can completely skip all that and then submit it. So that means you're taking the load off the manual data entry part and you're doing everything ahead of time. And the third option is, again, using Python IHM to create a near complete compliant file. But then instead of using the web interface, we also have an API. You can use the API to just upload and submit and do everything using the command line without using the web interface. And this is very useful if you have multiple entries. You don't have to go through that process. And you can use the API for doing multiple depositions. To access the deposition system, you can access it from the WWPDB OneDep system, or from the PDB IHM website, or directly through the deposition link here. You can start from anywhere. So now PDB IHM is part of the PDB, so there are multiple ways to access the system. We provide user guide and documentation. There are links here for the deposition system using the API and also how to use Python IHM. There are some examples. It may not be fully complete. It's work in progress. If you have specific use cases that you would want us to provide examples for in Python IHM, we can create some templates. We're happy to help. You can always contact us, give us your requirements, and we can provide examples that you can use. Next slide. Okay, so now going back to the most prominent use case, which is using the web interface without using the API or going through starting with a fully compliant file. What does the deposition workflow look like for the most common use case? You will create an account and login. I will go through this during the demo, but let me just walk through the workflow here. You'll have to create an account using Globus, which is our authentication system, login, and then you will create a new entry, a new deposition, and upload the coordinates. Let's say you're starting with a minimal MMSIF file with coordinates. The backend process, the software agent makes sure that your coordinates are correct. It's more or less reasonable to proceed. If there's an error, it throws an error and it comes back to you. You got to go and fix it. But otherwise, if everything is okay, you go to the next step, which is quite a bit of manual data entry through the front end. Metadata information, which could be your reference data, reference sequence, software, protocol, all that. You have to add your input data, what was used, whether it was SAS or EPR, cross-linking, that kind of information. You have to upload the starting models and restraint files. Here, the restraint files, what we currently support are CSV and TSV files, and these are required to be in a particular format, which can be different from what you internally used in your modeling. So you will have to make sure that you do that conversion from whatever state it is sitting on your desktop to this CSV or TSV that the system can accept, and then upload that. And all these steps can be skipped if you start with a compliant file. And then finally, once all that is done, we'll submit an entry, and then the system creates the full, complete MMSIF file. And once that's done, this is the deposition workflow. Once that's done, one of us, Monica or me, will go and check as a curator. We'll have access. We'll be able to check, make sure everything is there, whatever is needed for deposition. Make sure it's compliant, nothing's missing. And then we'll say, okay, it's all complete. At that point, accession code will be issued and validation reports will be created. You'll be able to see the validation report. And if you think that, okay, I did something wrong, there are too many validation errors and you want to go back and fix your model, you can at that point. That's the reason you can look at the validation report right after submission, so you can go back and fix. And then at that point, you can retain most of that you've manually uploaded. You don't have to go back and do the whole thing, but you may have to do a little bit of trial and error to make sure your coordinates are correct. Use this, whatever was created here, put that back into your file and then start. But we can avoid all the manual entry the second round. You wouldn't have to do that again. All right, so that's the deposition workflow. So let's go to the demo. Monica, do you want to stop sharing? Thank you. Let me. All right, so this is the PDB IHM website. Probably you start from here. There are links to the deposition system. You get here, and then there's information. There's a link to the user guide, how you create a new account, register using Globus. You have links for all that. Let me just quickly go to the user guide and go to the account creation section. There are instructions here, how to register using Globus. You can use your ORCID ID or your university account or even a Gmail account. You would need to register using Globus. You get to the PDB submitter group. You got to join the group, and once you submit the application, we get an email. We'll approve it as soon as possible, and then you'll be able to go to the system here and log in. So right now I've already logged in as a depositor just so I can walk through the demo. And then once you're able to log in, you get to the first link is the entry page. Sorry, I need to go to the all right. So this is our test system. I just had to, I'm logged in right now. And when you log in, you can look at all the different entries that the user has created. There are different, we created different entries to walk through this demo, but you can see all of them when you log in. So it's based on your either ORCID ID or institutional credentials or your Gmail account, and you can see everything that's been created. All right. And then you click on the create button. We request that you provide an image and an MMSIF file. So let me just do that. I'm going to use an existing example just so it's easy. That's the file, image, and then you start your deposition. And let's just say integrative model. It's good to provide a detailed text of what was done here, just so we get an idea of what was how the modeling was carried out. And once you create an entry and upload the file, it will show up here in the list. A new one was just created and a new background process has been triggered. So now this will be processed, the MMSIF file. While that happens, I want to go to one that we already created. The same file was uploaded. And you go here, you see the entry page, which has a lot of different information. The file was uploaded. If you didn't upload an image, it will say image needed. We recommend that you upload. And since this example started with a nearly compliant file, you'll see that a lot of information has already been populated. The author name, structure, citations. So depending upon what is in your input file, the data in the database gets populated. So the backend here is a PostgreSQL database, and it'll take what's in the file that's uploaded and populate that information. It'll tell you, for example, here, these are the different kinds of input data that was used: 3D EM volume, cross-linking mass spec, other starting models from AlphaFold. So different information was used. So all that gets populated here. If this wasn't the case, I have an example, I think, here, which is a file that just had the minimum coordinates with not much metadata. So if you upload that kind of a file, then you would only see basic what you can get from the coordinates. You can understand what kind of molecular entities were there, what amino acid residues and nucleic acid residues, and what kind of atoms. So very basic information that can be derived from the coordinates will be populated, but nothing else. As you can see, there's nothing about what input data was used or what UniProt accession codes. Nothing is there when you start with. You'll have to do all that manually. Like you'll have to get to that section and say, okay, I want to add input data. I want to say I used cross-linking MS. Then you have to create that information. You have to say I used cross-linking MS. And is that in the database? Hopefully, yes. You'll probably provide PRIDE accession code, something from PRIDE. And save that. If you started with a minimal file, that's what you would do. But for this example, it was already there in the MMSIF file, so everything got populated already. And one thing I wanted to show is, okay, so if you didn't start with didn't have restraints, we need in this case cross-linking restraints. You can upload CSV or TSV files, and for that, let's say cross-links from experiments. There are two sets of cross-linking tables that need to be populated. One that comes from experiments. This is where you identify this residue is cross-linked to this. That's what you get from the experiment. But then how you apply it in the modeling is if you have multiple copies, or there are ambiguous restraints. You want to extend it and apply to all kinds of ambiguities, and that becomes another table, how it's applied in the modeling. And you can upload the restraint file and set the workflow again so it can start the backend process. And we just uploaded the restraint file, and now that'll show up. It'll take some time to populate, but it'll show up in the uploaded restraint file section here. And when that's done, this table here will get populated. I think we have an example where that was already populated, where it was uploaded. For example, here, yes. So the restraint files were already uploaded, and the data now is populated. That's the restraint upload section. We went through the manual input data section. If you start with a minimalist file, there are other things you would need to upload, add again manually. Going back to the workflow, you would do manual metadata, input data, starting models, and CSV files. All that will have to be uploaded in the corresponding tables. And then finally, once all that is done, see, probably this is the example. Yes, everything is here. You would say, okay, I'm done. I have everything. And then I would say submit and save. And once that's submitted, it would go to, it will create the MMSIF file. And what I want to show here is your access control changes based on what the status is. As long as you're just starting to work on it, or there is an error that you need to fix, or you're working on manually entering, you will have write access. The minute you submit and it goes to other statuses, curation is being carried out, the entries either on hold. At that point, you don't have edit access. And if you want, you could ask us, and then we can, of course, change the status back. If you want to edit it, you can put it back and you'll have edit access. But the workflow itself, the access control is based on the workflow status. And I wanted to just highlight one of the error situations here. So this is a file that was uploaded, and you will see if it causes an error. Uploaded MMSIF file had a problem because again, this is coming from our backend software tool, but if you just dig a little deep, you'll be able to see IHM crosslink list. There is a linker type says test, and that's not an allowed value. Sometimes we have control vocabulary terms that say at this particular, just like in your Excel spreadsheet, sometimes you can have control terms. These are the only values that can be provided for a particular data item, and you have something else that's not accepted, then it will throw an error. So that's the example here. There can be other kinds of error. But if you're not able to understand, we can of course help out. All right, so let me see if any of our submissions got processed, just to show you what happens. This one, yeah, this one got pretty done, I guess. Maybe here. Right, so this is the first one we uploaded. Now we started the deposition. It's ready. So you can go and update entry. The other one is still being processed. It takes some time for the backend to complete its job, but it'll be done. And once it gets to MMSIF created, you lose access. We will review it and then put it on hold, at which point you will have accession codes. Let me show you, for example, validation report that gets issued at this point. You have accession code. You will be able to see the structure with the embedded, using the embedded multi-star. This is a coarse-grained multi-scale structure. You can visually inspect, and you also see the created MMSIF file, which includes all the metadata that you might have input manually, the restraints that you might have uploaded. All that information gets packaged, and then you get to see the validation reports here that is generated by the system. You can see the full report. I can show you another example with maybe atomic coordinates. Oh, this is not atomic. Okay. Yeah, you get to see the validation report. This is based on cross-linking data. So there is a section based on fit of model to cross-linking data. We pull the data from PRIDE and evaluate the model based on the restraints that were used. So you can look at what are the percentage of satisfied restraints and violated restraints. That's the full validation report. And then there is a summary that just summarizes what is this model, what is the composition, what data sets were used, just to summarize what's in the full validation report. And these are based on recommendations from the community. So, yeah. And then at this point, the entry is on hold until it can be released, either when the publication is out, or when 6 months to a year, depending upon the structure.